Hi everyone, and welcome to the following of bonding curve integral.sol, and in this part we're going to complete the functions. So the next function here, which is the most important one and serves the main purpose of our smart contract, is the calculating of if amount, which is going to be written in a much different manner than what we had in the previous contract. So now let's get started here, and let me make sure that we are inside of the correct contract. Yes, this is bonding curve integral.sol. So I will keep these other two open. So notice that this is the first bonding curve, this is the second one, and bonding curve integral.sol is the third one. So we had three versions, and the most correct one is this one. So function calculate if amount. Calculate if amount. So the variables that we'll get is the token amount and the boolean, which is buying. So uint 256 token amount, and bool variable buying. So it will let us know whether we're buying or selling, and whenever you want to use it, it will determine whether you're buying or selling, and accordingly it will calculate the amount. So returns view returns uint 256. So the first thing which we're going to define is uint 256 initial, and I will tell you what this is for. So the initial value of initial is 0, and uint 256 f, which stands for final. And notice that if you write final instead of f, it will be an error because we have final for something else in Solidity. So f equals to 0, and notice that whenever you want to calculate an integral from one number to the other, then you will need to have an initial value up to a final value. So you calculate the formula of integral for both one of them, and then we will subtract the final value from the initial value. So imagine that we have a curvature, and that curvature is, for example, like here is a parabolic curvature. We want to calculate the area under that curvature from one value to the other, from the initial value to the final value, right? So for example, if you want to buy something and the bonding curve of it is parabolic, so it starts from one value, which is 0, to the for example, most of the time our example worked with 7, so from 0 to 7 we will calculate the integral of that formula, which is a multiplied by x to the power of 2 plus b. So we had this right over here. Let me show you. This was the formula, ax to the power of 2 plus b. So this x was supply, and the resulting value will be the price, right? So in order to calculate the price for all the tokens, we can use the integral formula to be able to calculate the area under that curvature, right? So in order to do that, all we need to do is to calculate the integral first. So I will have a function for calculating the integrate. Integration of this formula, and then we'll calculate the amount for the amount of it for initial value and the final value, and then subtract them from each other so that we finally calculate the area under the curvature for for that specific number of tokens, and it depends the total supply at the beginning of buying or selling, and also the total supply that will become after the buying and selling. So if you do not understand what I'm saying, make sure that you follow along with this part, because this is super important, and you will understand what I'm doing at the time that I'm doing it. So if you're not familiar with calculus or integral, I'm suggesting you to follow this bonding curve 2.sol, because this is going to work exactly the same but it's not as optimized as the bonding curve integral of solve. So this is much more optimized, and it's a very simple mathematical concept. But if you don't understand it, or if you haven't ever learned it, you can go and Google for it, how integral works and why do we use it. But if you are already familiar with the calculus and this very simple integral that you're using, then you can follow along with this one and you will simply understand it. So anyway, we have the initial value and the final value, and then we'll check whether we're buying or selling. So if buying, which when we say if buying, means if buying equals to true, which means if we are buying, then open the brackets. So what we're going to do here is to write initial. So the initial will change to integrate, and integrate is a function that I'm going to write later, but it will get the supply value, and then what I'm going to do is also calculate the final value. So f integrate the supply plus token amount, supply plus token amount. Here we go. And then we'll go after the else here. So else, open the brackets, and if you're selling, then the places of the initial and the final value changes. So the final value is the value of right now, because the number of tokens are decreasing, and because you do not want to have a minus amount for the resulting value, which is the subtraction of final and initial, we don't want it to be negative, because we're defining it to be positive with uint 256 instead of int 256, then that is happening. We want to write the initial equals to the so first of all, let me define the f value. F equals to the integrate. So you will understand. Don't worry if you don't get it up to now, because I'm not sure if you got it or not, but you will understand. So the initial value here, it will become the integrate, which is actually the final value, but we're writing this because we always want to subtract final from the initial, right? But the initial value is the supply. Always it is the supply at the current moment, but right after we buy it or sell it, it will change, and the change is either plus token amount or minus token amount, right? Based on whether we're buying or selling. So now the initial value, because it is a smaller value than the total supply, will be the supply minus token amount. Supply minus token amount. So you can write it in a different way. You can write the initial equals to integrate supply, and the final value integrate of the supply minus token amount, and that will be fine. But notice that the resulting value will be negative, and here I do not want it to be negative, so that's why I'm doing it. So the resulting value uint 256 will be the ETH amount. So the ETH amount will be the result of the subtraction of the f subtracted from the initial, and here we go, it will be the value just like that. So just like that, we will get the ETH amount, and then we'll be able to return it. So return ETH amount. Here we go, and that's it for this function. So here, notice that we should also write the integrate function. So we'll write function integrate. So we'll get the uint 256 number. So the number that we enter here, which is right here, was supply, and based on the circumstance, it will change accordingly. So here, consider it to be a number, which is u into 56, and public pure returns u into 56, which is the resulting value, and here we go, we enter here. So u into 56 results, and this is the formula of an integral, right? So a multiplied by number to the power of 3. I will explain why this is happening. So power is written this way: 2 multiplications in solidity will be the integral. Actually power, actually. So, and divided by 3. So this is the integral of a multiplied by number to the power of 2. So the integral of this sentence will be this one. So the power will increase and it will be divided by the power that increases, right? And for the next sentence, it will be it was b, it will become b multiplied by supply. So notice what we had here in the previous contract. It was a multiplied by supply to the power of 2. So here it becomes to the power of 3. This is the formula of integral, and it will be divided by the power, right, which is 3. And here the power will increase by 1. It is 0 right here. It will become 1, and it will be divided by 1, which becomes itself. So it will be b multiplied by supply. Here supply is number. So number in this formula. And here we go. So we'll return the result right over here. Results, and there we go. So I don't need to write the next function, but this is necessary whenever you want to check the price. So I can copy and paste it from the previous contract. So get the price, and here we'll get the supply and calculate the price of the current moment. So it will follow the formula that we have right here. Let me write the function get current price. So this sentence right over here is the integral of this sentence, and this sentence is the derivative of this sentence, right? So anyway, all we need to do right now is to also copy and paste the receive and fallback functions, and then that's it. We will have the smart contract completed. Anyway, so let's save it, and there seems to be one error, but we will compile it in the next part. So it will compile it, test the contract, deploy it, and so on in the next part. So until the next video, goodbye.